Good day, everyone, and welcome to yet another exciting episode of AI Climbing with Sheikh. And this is a sort of part three of our series how we can improve and enhance the performance of AI models so that we can trust it with data, benchmark it, and basically make business out of it. So I hope you have seen the earlier episodes, the part one where we build a local AI PDF assistant and solving a lot of issues for enterprise and local. Part two, where you will basically see how you can enhance the performance using teacher-student models, and part three, where we will implement a dynamic loop back and feedback. And we need to actually, first of all, understand all of those different architectures. And here I will be strongly trying to implement the lab architectures. Again, what is lab architectures? If you can see this paper, this is a large scale alignment for chatbots, and the whole idea is, right, these LLMs hallucinate, and then you should be able not only to update with data, which RAG and few other stuff do, but also the context and make it fine tune and match to your needs. And how we are going to do that, and before that, these are our channels. If you are enjoying, do like, subscribe, and share with the people who interested. And if you can see over here that different feedback mechanism exists, but here we will be applying the lab architectures, which is more like a open source approach to improve the performance of LLM. And Instruct Labs is something perhaps I have a better expertise, and obviously, as you can see, closely working with the OpenShift AI, and the whole idea is to democratize AI, right? Instead of doing lot of expertise in AI and reading papers, the whole idea with the Instruct Lab is to make it easy to both use and contribute and share. Actually, you can consider it more like a model, like a tree, and then in this tree certain nodes are you, and you can enhance and actually push it back, and then others can use. It's quite good actually. And it is plays a crucial role in the open source models from IBM Granite, again heavily used not just in Red Hat, in others as well, apart from Hugging Face. And then combining Instruct Lab with RHEL AI, right? You no need a cloud. You actually run this whole models out of box in RHEL AI like Podman Desktop. Again, a good thing to try. And the whole idea is adaptability, right? Like you face challenging to adopt pre-trained models. You can't trust them, and if you try to tune, maybe it need lot of GPUs. No easy way to go back, no a GitHub or a Git push way, and then high dependency on human generated data. So I was reading a sort of a report, and they talk about pre-training and fine tuning. I hope apart from the Moore's law and the Amdahl's law, you can Google it and you will know these are the two laws primarily dictating over compute history, both in CPU and the HPC, or high performance compute. Looks our friend Jensen is has too much money, and obviously he want to be famous. So there is a new law which is coming as Jensen law, and this is the test time AI, right? And the whole idea of test time AI, more and more queries and inference. But then I think the laws of scale tell something else, and that something else means that models need to be efficient, and then there is a lot of synthetic data. Why? Because in an enterprise world, nobody will give you 100% of data to fit your need. Consider a case, right? Like You are in a hospital and doing lot of this enterprise healthcare, and you are modeling patients and diseases, deaths, and all those, and then you don't get death data, right? So the whole idea is with partial data how to do it synthetic and make it work. So it's very important that we apply and see how this teacher student architecture works here. Again, a snippet here. And again, what you are seeing over here is more like a taxonomy. So, you know, the idea of taxonomy is more like a tree root and childs, and then you can delete certain childs if it is conflicting with your view of the world, and then you can add, replace, and push. So that's pretty much what the lab architecture is. And if you can see over here, without lab architectures, the actually with them, even the input distributions, right? Like what contacts are coming are dynamic, and then through lab you will trim, clip, and then homogenize all of those. So that is actually the main idea over here. And again, a sort of some sharing around instruct labs. As you can see over here, this is more about learning and trying at a lower scale, then push it at a bigger scale with rel AI on the cloud, a big cloud, a country cloud, and so on. And that's pretty much on the PPT side of the world. And now we will let's try actually go through the paper as well. Again, highly encourage, and you can see over here again, not very very old, although it's a big old in the context of AI. And 6 months research changes the game, and we have seen it with DeepSeek. And Mr. Musk also launched his model. Perhaps things are not open because, like APIs, he don't want to share. And we'll see through the community how we can understand and learn from it. But here you can go through a paper, but the whole idea I already explained to you, right? How this lab and teacher student thing works. Distribution, go through it again, is a good chance at some video to record how these two work. But let me now go to our code piece, and again, I highly encourage, if you have not seen the earlier episodes, go and watch it. And here, if you can see, the main core logic will be the same, right? And what I am going to change is mainly the last piece over here, right? And as you know, like if there is nothing coming from the user document, actually it will ask the user QA input, right? And by this input, actually it means that you can add a context into it, and then that context becomes a north star for the model to query. And if that is not, then pretty much it will go to the teacher model again with the context what you have typed, and give you the response. So as you can see, ultimately you are able to adopt and give the inputs over here. Again, it's a streamless app, so let me try to run it. And since it is a live demo, so I am not sure it will be working or giving an error. But looks it works, and this time we will put another document. All right, AI ran Alliance. Again, some exciting work we did with our folks in NVIDIA. And let's try to see that how it behaves. And if you can see over here, it's going and it's checking, and let us try to see. All right, can you explain lab architecture, which is what is which is all right. Sorry. Yeah, let me see over here. Lab architecture document is over here. And let's change it a bit. Large scale alignment. All right. Instead of large scale alignment, we can say that you can give me large scale instead of alignment, large scale attention. All right. So all I am going to do over here is ask a question and let's try to give a context here. Lab is LLM alignment for all right. Large scale alignment for chatbots is so. Yep, it will now proceed, and if you can see over here, it is trying to go through the document first. It don't find the document and go to the context and then to the teacher model and gives you a answer over here. It needs some for sure some sort of more tuning over here and perhaps a new architecture, but that's I think pretty much the whole idea that how you will chunk your documents and then how you will apply the different feedback loops to make it work. So that's pretty much all. And if you are don't forget to subscribe and share this channel. And all of the code will be available in few days on GitHub. And thanks for joining. And let's try to build something good together and see how we can build the AI systems which are more trustworthy and reliant with data. And thank you very much. And that's pretty much all for today. Take care. Bye.